Hello everyone, welcome back. Today we will learn how to find the equation of a line. So our goal is to be able to find the equation of a line using the slope-intercept, point-slope, and standard forms, and then also explain what those are, and also be able to find the equations of horizontal and vertical lines. So first, let's start with what's the most common form of a line, called the slope-intercept form of a line. Now, actually, before we get there, let's mention briefly something important distinction. Here we're talking about linear functions. So a linear function, just a reminder, okay, what a linear function means is that all variables, however many you have exponents of 1. Okay. What that means is no matter how many variables you have, each variable that's there has an exponent of 1, not 2 or 3, anything like that, but not 1. Look at examples of linear functions. Okay. Some basic ones. So if you have like y equals 2 or y equals 3x minus 1, or say 2x plus 3y equals -7. These are all linear functions because no matter how many, or even if we do 3 variables, x minus 4y plus 3z is equal to 1. These are all linear functions because the powers of our variables, x, y, and z, how many variables we have, they're all to the first power. Now, the things that are not linear functions, okay, would be, for example, if anything is like, say, something is squared, so y equals x squared. And also the graphs of all these are, especially in 2 dimensions, are straight lines. Okay, in 3 dimensions, they'd be planes. For example, this is the graph of a parabola, or maybe y equals the square root of x plus 2. Or if you have any other kind of like e to the x, y equals the natural log of x, anything like that. Okay, trig functions like y equals sine of x, or anything, like different powers, like y equals x to the 2/3. Main thing is like other functions of x, like exponents, logs, sines, or any power that's not 1. These are not linear functions. So you graph them, these do not give you straight lines, but linear functions, at least in 2 dimensions, will always give you straight lines. Okay, that's just a brief reminder. So here we're focusing on linear functions. Specifically, the slope-intercept form of a line looks like y equals mx plus b, where m is the slope and b is the y coordinate of the y-intercept. The y-intercept is 0b. This is called the slope-intercept form of a line because of those two things. It's the most useful form of a line because from this form you can pick out right away what the slope and the y-intercept are. Now, let's come down a bit further. So our goal then is to be able to find the equation of a line, and there are basically 3 cases we have in doing this. So it depends on what you're given. So if you know the slope of the y-intercept, that's the easiest case. Just have to plug those in. Also, if you know the slope and a point on the line, and also if you know 2 points on the line. Let's look at the first. Looks like each one of these cases. So I want to find the equation of the line. Okay, so number one, what I'm given, is the slope m equals 2. The y-intercept equals -3. So this is the y-coordinate of the y-intercept. Okay, and here what I want to get out of this is my slope-intercept form. Y equals mx plus b. Okay, well, this is my m, and then this is my b. That's the y-coordinate of the y-intercept. So this is the easiest case. I just simply plug those in. And so we have 2x minus 3. Okay, so you graph that line, then that's a graph of that line. And that's the only line that has a slope of 2 and has a y-intercept of -3. That's the easy case. Just plug those in. Now, look at case number 2. So in case number 2, I'll know the slope, but I also just know a point on the line that's not the y-intercept. Okay. So this time what I know is I'm given the slope, m equals -4/3. And what I know is a point on the line. Okay. And the point on the line I know it goes through is 1, 5. Okay. So in this case, then, I still want the same thing. I still want slope intercept form, y equals mx plus b. Okay. So I know my m, I don't know my b. I need to find b. And so I can plug in, I'll just say, so what we have so far is we can plug in the slope. This is -4/3 x plus b. So then, of course, I need to find b. Okay. How do I do that? Well, since I have a point on the line, once again, of course, this is not the y-intercept. I can't just plug the 5 in. What I do is plug in the point. Okay, and solve for b. So what I mean then is we look at this, so y is equal to 5. And then we have -4/3 times x, which is 1, plus b. And then I want to solve for b. Okay, and so this gives me 5 is equal to -4/3 plus b. Okay, now we have to deal with a fraction. There are a couple ways we can do that. Let me write this better. Okay, the way I'm going to do it is I'm going to find a least common denominator. You can also just work directly with fractions. I'm going to find a least common denominator, an LCD, which is just 3, since that's our only denominator, and multiply both sides by 3. This will allow me to get rid of my denominator. So, of course, 3 times 5 is 15. Over here, I distribute 3 to each part. So I give 3 times -4/3 plus, since it's a plus, 3 times b. And then this is going to give me, once again, 15 is equal to, 3's cancel out. And so I have -11 plus 3b. Okay. Now I have an equation for b with no denominators. So add 11 to both sides. And so that's going to be 26 is equal to 3b. Divide both sides by 3. And so that b is equal to 26/3, which unfortunately doesn't reduce. So the equation of my line is y equals -4/3 x plus 26/3. And that is the equation of my line with that particular slope, and also that goes through that point. Also, let me go and circle the one up here while I'm thinking about it. Okay. And that's the only equation of a line that has that slope and goes through that point. Okay. Now, let's look at case number 3. So in case number 3, I know 2 points on the line. Oh, wait a minute. Hang on. I'm sorry. I made a mistake. It's a 4, not 11. Okay, let me do that again. So I'm sorry, that's a 4. That's -4. Okay. And so if I add 4 to both sides, it becomes 19. So b is 19/3. There we go. A 19/3. Okay, which still can't reduce. Now that's correct. Okay. Look at number 3. Number 3 is this time what we know. We know 2 points on the line. Okay. And the 2 points on the line are 2, 3, and -5, 7. Okay. So we know that these 2 points go through some line, or 2 points on a line. So we want to find the equation of that line. Okay. So once again, we want the same thing. What we want is the slope intercept form, y equals mx plus b. Unlike the previous example, we don't know, in this case, we don't know m or b. So first, we need to find m. Find the slope. We know how to do that if you've seen my other video on find the slope, or you know how to find the slope before. So the slope is the change in x over change in y. And so that's going to be 7 minus 3 change in y over negative 5 minus 2 change in x. So 7 minus 3 is going to be 4. The number 7 over 2 is negative 7. And so this is, let's bring the negative up front, negative 4 sevenths. Okay. So what we have so far is y equals negative 4 sevenths x plus b. Okay. Now, like the previous example, we just need to find b. Okay. Now, in the previous one, we plugged in the point we're given. This time we have 2 points. So we can use either point. Okay. That's up to you. So use either point. And sometimes one might be easier than the other. It just depends. But we can use either point because they're both on the line. Okay. In this case, I'm going to choose to use the first point. 2, 3. So I'm going to plug that one in to this. So that's going to be y is going to be 3 is equal to negative 4 sevenths times x, which is 2, plus b. Okay, this will become 3 is equal to, this is 2 over 1, multiply straight across for fractions, negative 8 sevenths plus b. And like the previous example, I'm going to use an LCD of 7, multiply both sides by 7. So this side will be 21. Here, 7 times negative 8 sevenths plus 7 times b. Here the 7s cancel out. I have 21 is equal to negative 8 plus 7b. And now I have an equation with no denominators. I'll just solve this for b. So add 8 to both sides. That's going to be 29 is equal to 7b. Divide both sides by 7. b is equal to 29 over 7, which doesn't reduce, unfortunately. And so, but I now know the equation of my line, y equals, what's my slope, negative 4 sevenths x plus 29 over 7. Now, if you try the other point and do the same thing, it might be a good exercise to do on your own. We'll see you get exactly the same thing. Okay, next idea. I described each one of those before. Okay, now let's talk about the next idea, something called the point slope of a line, the point slope form of a line. Now, this one is not as useful generally as the slope intercept form, but it can be helpful in some cases. So the point slope form of a line. Okay, so look over here. So this one, I'll just rewrite this equation here. Y minus y1 is equal to m times x minus x1. It's called the point slope form because you plug in a point, x1, y1, and and where x1, y1 some point on the line, and the slope is m. Okay. Yeah. So I'll just say this. So for a line that passes through point x1, y1 with slope m. Okay. Now let's look at an example. And what we want to do in our example is want to write in slope intercept form. We're going to start out in point slope form, then go to slope intercept form. Okay. For, let's say we know this time, m is equal to negative 4 thirds, and the line through 1, 5. So we've already done this one. Okay. We're going to show that we get exactly the same result. Okay. We're going to plug it into this. Okay. So we have y minus y1, our point, the y coordinate of our point, which is 5, is equal to m, which is negative 4/3, and times x minus our x coordinate, which is 1. Now, also, one thing to be aware of here, also, these negatives are part of the formula. So if your point itself has a negative coordinate, then you're going to be subtracting a negative. Just keep that in mind. Okay. Now, once again, what we want then to write as y equals mx plus b. Okay. So essentially, this is another way to get to the same place. Okay. Just plugging in, instead of plugging the slope and point the slope at the same time. Okay. So what I want to do then is actually want to distribute this negative 4/3. Okay. All right. So then we're going to have y. Ooh, what just happened? Okay, that was strange. Went into my sheet. Okay. So then we have y minus 5 is equal to, so negative 4/3 x times negative is positive plus 4/3. Okay. Now, I need to add 5 to both sides, get y by itself. Then we have y is equal to negative 4/3 x, then plus 4/3 plus 5. Now here, we could also do the same thing we did before and actually get a common denominator. I'm going to do this a different way. This practice working with fractions. So what we want to do is basically write 5 with the denominator of 3. Another way to do that then is 5 is the same as 5/1. Multiply the top and bottom by 3. We have to multiply the top and bottom because 3/3 is 1. We're not changing what 5 is. We're just writing it with the denominator of 5. This is to become y equals negative 4/3 x plus 4/3, and plus 5 times 3 is 15, and then 1 times 3 is 3. Now they have the same denominator. We can combine this, and y is negative 4/3 x plus, that's going to be 19/3. And if we look back in our notes, we'll see it's exactly the same thing we got before. Right. Same thing we got for that same example we did in a different way. We got exactly the same result. And this is the same thing. That time we just used directly the slope-intercept form. We got that equation. This time we used the point-slope form, and we got the same equation. So that shows we get the same thing. Okay. Now let's also talk about a few other forms of the line. All right. Something called the standard form of the line. And you see the standard form of the line. Let's look at it over here. Okay. Looks like, in general, looks like this. AX plus BY is equal to C, where your A, B, and C are constants. Okay. Now, I also mentioned that over here. Okay. And also A and B are both not 0. And also, typically, that's not necessarily a strict rule. A is often positive. So if it's not positive, you just multiply everything by a -1 to make it positive. So let's actually take our last example and write it in this form. Okay. So let's write, I'll set this as an example. Let's go down here. So let's write our previous one, y equals negative 4/3 x plus 19/3 in standard form. Now, standard form is not as useful in most cases, but one place you will see it often is if you're looking at systems of equations where you have more than one linear equation, and often you see it in that form. Okay. Well, One good place to start is actually to get our denominators in this case. So we're LCD, because we don't have any denominators here. Actually, our ABC, or constants are typically just integers, no fractions. So LCD is 3. So multiply everything by the LCD, both sides. And that's going to get rid of our denominators. So we have 3y is equal to, distribute the 3. So we have 3 times negative 4x over 3. Then plus, so we have a plus 3 times 19/3. Once again, as I said, this is going to get rid of our denominators. So the 3's cancel out here and here. So we're left with then is 3y is equal to negative 4x plus 19. Okay, I actually just have one more step then. Just add 4x to both sides. We want to get our variable terms on the same side, and we have 4x plus 3y is equal to 19. Okay, and that is the same thing. That just simply is another way to write the equation of that line. And as far as better or worse, well, not necessarily either one. It's just a different way of doing it. In some cases, it's more useful, but in many cases, it isn't, because you can't pick out important things in the line. So for here, this one, if I just give you this equation, I know right away the slope is negative 4/3, and the y-coordinate of the y-intercept is 19/3. In this form, I don't know that. I don't see that right away. And also the slope is not what's in front of the x here. Okay, so only with the slope-intercept form that's true. So it's a lot easier to figure that out, and also kind of a lot harder to get the feel for what the line is telling you, what the line looks like. Okay. Now, let's take a look at an example where we want to go the other way. This time, what I want to do is I want to start with an equation in slope-intercept standard form. I want to write in slope-intercept form. Okay, so start with an equation like this and write it in slope-intercept form. This time, we'll do a different example. I'm doing the same one. All right, so let's say we have 4x minus 2y is equal to 8. Okay, well, so essentially what we're doing then is just solving for y, or getting y by itself. We solve for y, so first subtract 4x on both sides. That gives us negative 2y is equal to negative 4x plus 8. Okay, then, of course, you can imagine divide both sides by negative 2. So here the negative 2 cancels out. I'm left with y, but we want to make this, separate this. So since I'm adding or subtracting between these, I can write this as two different fractions. I can write this as negative 4x over negative 2 and plus 8 over negative 2, and then simplify. And so here I have 4 over 2. That's going to be, of course, going to be positive, and it's going to be 2x. And then here, this is going to be negative. A positive by negative is negative 4. And now that is the same equation as this, just written in a different form. Okay. In fact, let's show that. Let's go to Desmos. Remember, this is dsmos.com. And let's actually graph both of those. Now, in a graphing calculator, you probably have to write it in slope-intercept form. But Desmos, I can do it in either form. So first off, y equals 2x minus 4. That's a graph of that line. Now, let's graph the other one and make sure we get the same line. 4x minus 2y is equal to 8. Yeah. So I turn one off and on, exactly the same line. There's a different way to write it. Okay. All right, the last thing I want to talk about today are horizontal and vertical lines. Okay, so if you know about the slope, if you've seen my other video on the slope, you know that if a horizontal line is a line that has a slope of 0. If it's flat, it means there's no, thing of slope is rise over run. There's back and forth, but there's no rise. There's no up and down. And a vertical line has an undefined slope. So there's rise, there's up and down, but no run. Okay. And also, a horizontal line is an equation y equals a number. Okay. the y-intercept of 0 in that number, and a vertical line has an equation of x equals some number, and the x-intercept is a, dash 0, and also has an undefined slope. So let's take a look quickly at these. Horizontal and vertical lines. Okay, let's look at the example. So want to find the equations, abbreviate that, of horizontal, abbreviate that, and vertical lines through the point 2, 3. And also here, for a moment, I need to get a grid as well to do that. Let me come down here. Paste my grid. Make sure I can move it around. Yes, I can. Let me move it right here. Okay, so first, let's just find this point on here, 2, 3. 2, 3 is right here. Okay, so, of course, the x-coordinate is 2, the y-coordinate is 3. So what this is a horizontal line. Let's say but the horizontal line first. It doesn't matter which one. Okay, so basically it has the equation y equals b. Now the thing about a horizontal line is, or b essentially is what we call the y-intercept, or b is your y-coordinate. Okay, and what's true about a horizontal line is that y is always the same value. Okay, so this has the equation y equals 3. Okay, because if it's horizontal, it also has a point right here. Okay, 0, 3, that's my y-intercept. And it's horizontal because if I draw this line, I hope I can draw a straight line, y equals 3. One of the reasons it's horizontal, because you notice our slope is 0. Okay, and also y, and it should be a straight line, y is always 3. No matter what x is, y is always 3. So also a point -7, 3 is on that line, because no matter what y is, x is, y is always 3. Then a vertical line, okay, has the equation x equals the x-coordinate of the point it goes through, x equals 2. A similar way, for example, a point on this line, the x-intercept of this line is 2, 0. And it's a vertical line going through both. Well, that again. Let me try that one more time. If I can draw a straight line. Okay. Wow. Having a hard time drawing a straight line between these points. So I just have to imagine it being straight. Yeah, I'm sorry, I just have to imagine this being a straight line. This is my writing pad having a little trouble doing that. Wow, this is bad. Okay, that should be a straight or vertical line. Or x equals 2. And once again, it's the equation is x equals 2 because as a vertical line, x is always 2. Okay, in this case, when y is 3, x is 2. When y is 0, x is 2. If y is -10, x is also 2. Doesn't matter. The y is irrelevant because x is always 2. And this, the slope, m, is undefined. Okay, so that's what the equations of horizontal and vertical lines look like. They're always, horizontal line is always y equals a number, y equals the y-coordinate of any point it goes through. And a vertical line is x equals a number, x equals the number of the x-coordinate it goes through. Okay, and so that's how to find the equation of a line. So let's briefly review just a moment, see what we looked at. So we wanted to find the equation of a line in slope-intercept form, y equals mx plus b. This is the most useful form of a line. Looked at 3 cases. The easiest one being, the slope and the y-intercept, you just plug those in. The slope and a point on the line, you plug in the slope and then the point on the line to find b. M, you don't know b. 2 points on the line, you have to find both m and b. You find m first, and then use either point to find b. Okay, we talked about the point slope form. We can plug in the slope and a point at the same time. And then also we did the standard form or standard equation of a line looks like this. And we were able to convert back and forth between that and slope intercept form. Then we learned how to graph horizontal and vertical lines. Thank you. Have a good day.